All right, YouTube, welcome back. We're going to take a little break from the computer with transistor video. Kind of stumped on how to get this thing working with the bus. But anyhow, I'm getting sidetracked, so I figured, well, I might as well make a video about the circuit board that I'm getting sidetracked with. So take a look. Okay, I was given this circuit board and asked if I could fix it. Was told it was for a bathtub, like a jacuzzi tub type deal. So I started checking it out. I found this paper, Kohler parts from this website, that basically gives a theory of operation and a really rough schematic. You can kind of follow some of these traces, but I got a pretty good idea of what's going on here. And so let's take a quick look here. I printed out this page as well. I believe this right here is the type of, cover that goes on here. And whirlpool timer conversion. I believe this is a Kohler circuit board. Let's see. Foil side. I also believe, Kohler. See, it says right there, you can see it says Kohler foil. And I just looked up this number here, this 60257, which is where I got this. Actually, there's a whole booklet for it, but I only printed. I was only interested in this board. There was a whole booklet for that tub, but I was just interested in this board, what each wire was. And it gave me like a voltage. It looks like it used to say 3.5 to 6 volts DC, and somebody wrote 5 to 14 maybe. So it just tells you what's what here with the wires. Pin 1 and 5, power, level control. So there's a float switch. It's connected to pin 3. Water level is too low for safe operation, and L appears on the digital display. Prevents whirlpool bath operation. Okay. Whirlpool operating time set by closing contacts is set time. Push button SW1. Last operating time shown in digital display. The setting is put into memory. All right, so let's put some power on this board. Start, stop, push button SW2 turns the bath on and off, causing the microprocessor to activate and deactivate the relay in the power panel. I wish I had the power panel. I asked him if he could get me the power panel from this tub. So we'll see. That may show up here in the next video of this. This is going to take me a minute to figure out. Anyhow, so that's what we got. Hang on a second. Let me get set up here and we'll check this thing out. Okay, so this is what I got going on. I got my PC power supply. Don't have an oscilloscope, but we're going to make do here. Got the board here. I just wired some jumpers onto the pins there. Over to a board here just to make this a little easier. This could be bad. These two get mixed up. Okay, and got the ground of my meter tied there, so I can to the ground here, so I can just probe. So let's crank up the juice. See what shakes loose. Ooh, 11.5 volts. That's kind of high. I mean, it's set up to 14, right? Written. It's at only 6. But I know the chip here is a 5-volt voltage regulator that can handle 35 volts. So I'm sure we're fine. Okay, it says 18. Why does it say 18? So these are the two switches here. Switch 2 and switch 1. And according to the paperwork, switch 1, set time, push button, switch 1. The last operating time is shown on the digital display. Pressing and holding allows selection of running time. So switch 1. All right, let's press switch 1 and see what happens. Nothing happens. Press and hold it. Nothing happens. Okay, could be the reason why he's asking me to fix it. Let's see what else we got. Switch 2, start, stop, push button, switch 2 turns the whirlpool bath on and off. Push switch button 2 and see what happens. Nothing. It does nothing. Nothing does anything. I wonder if my voltage is good. I'm like, pins coming off is driving me nuts. Full power off here. Okay, we got something different. We got an L. This one said we would get an L. When the water level is too low for safe operation, an L appears on the digital display. Well, that comes from pin 3. So pin 3, let's see what is on pin 3. It's pin 1, 2, 3. This is the middle one either way. Oh, yeah. Pin 3. We got 1.875 volts. Hang on a second. Let me bring up another page. Okay, so I learned a couple of things. Here's the power panel, theory of operation. 3 to 5 volts across the EMF. So here's the circuit for power. This is solid state relay. They're saying contacts EMF. Oh, F, E and F. Okay. So between the black and red wires. Yeah, because here's the hot for the motor. Hot coming in your line. Yeah, so this red would turn this relay on to turn the motor on. That's what I'm thinking. Okay, so I guess it's saying the theory of operation for the motor is you're going to see 3 to 5 volts across D and F for the motor to turn on. Power panel can. So here's what else I learned on this page. Theory of operation for the water level float. So it's saying normally closed when the water level is low. So it's grounding that pin of the microprocessor, causing flashing L to appear on the display. Okay, so it's saying L for low water. So this pin number 3 should be grounded, which makes sense because the level switch goes from ground to the ground. Well, it's the ground side of the other side of this transformer. Looking at, there's a diode there. So ground and the yellow or white, which is pin 3. So it should short pin 3 when the level is low, according to the theory of operation. So pin 3, it's saying low, should be shorted to ground. Can't ohm it out, but I can see it's at 1.87 volts. So it is not shorted to ground, even though it has an L there. So because it's not shorted to ground, it should let the motor start, right? And let's see, the motor is on here, and it should say 3 to 5 volts. If it's, yeah, look, it's 4.8 volts. So it's telling the motor to run right now, even though that has an L. So this is some funky stuff going on here. Now the L is gone. I hit it to run, and the L is gone. Let's see if anything changed. Still got 4.8 volts. Still got 1.8 volts. There's the L back. I hit start, and the L came back. Oh, now the L is gone. Press timer. L comes back. One time only. Press the timer. Start, and it tells me low. Okay, interesting. But it's not low because it's not shorted to ground. Well, if I short it to ground, which I can do right here, orange is ground, and brown is pin 3. Are we grounded now? Yep, we're grounded. Now it should say low. But nothing changes. Still just gives that L one time for every. Interesting. Okay, well, let's just see. I mean, obviously the buttons are working because this switch goes to here. Hang on, let me get the camera set up on the tripod. So where was I? I know pin 39 was connected to one of them. It's at 4.8 volts right now. Oh yeah, when I press this switch, it goes to 0 volts. So that's working, and I believe pin 1, which 1 is tied to pin 1, it is also sitting at 4.8 volts and goes to 0 volts when I press the switch. So the switches are working, which I figured they were. It's just like this thing's not. First of all, let's just see. I know we got 11.4 volts coming in. Here's this voltage regulator. 10.6 because there's a diode drop there. It's regulating it to 4.84 volts, which I think that's within spec for a 5-volt regulator. This should be ground here. It is. So our 5 volts is working, obviously, because we saw 5 volts here anyhow on these pins. This is just the display driver. We saw 1 and 8 completely lit, so obviously this a buffer or whatever it is for the display here seems to be working. But it's almost like the program is messed up in this chip, because when I short this, then it should give me the L. Right, but right now it's at 1.8 volts. I'm assuming it's not floating. I'm assuming there's a resistor to power somewhere, like a voltage divider or something that's causing it to have 1.8 volts until you short it to ground. This capacitor, I believe, looking at this circuit here for the power panel, I mean, it looks to me like you'd have AC coming here, right? There you go, winding. This be DC, although it shows like a little diode there. I suppose it could be pulsating DC. Because I thought, well, maybe this capacitor's dried up or something, and that could be causing some issues. But the problem with that is I'm supplying it with clean DC, so I don't think it would need this capacitor right now to work. I don't have an oscilloscope. I can't really look at, what this oscillator's doing. I'm not sure. I'm guessing it's a clock for this thing. So, I mean, there could be a problem with that. I don't know what this capacitor is doing. Could it be have something to do with this oscillator? Let's see. This chip. This is an Intel 8048 microcontroller chip. I learned that they started making these in 1976. This one, I believe, was made in 1977. So, I mean, they got their money's worth out of it, that's for sure. What else on this board? Like, really, I'm not sure what this transistor does. Let's see if we can see on this schematic. That transistor is right here. It's so hard to see where things go. That is pin 21, it looks like. Turns this transistor on for 4. That's number 4. 1, 2, 3, 4, 5. Pin 2 is connected to nothing. Pin 3, pin 4 turns the motor on. Okay, so that turns the motor on. So this transistor turns the motor on, right? Yeah. Yep. That would go to pin 4 to turn the motor on. Interesting. So that tells me that pin 21, I believe this is 40 pins, so pin 21 is at 4.8 volts on the base, well, through a resistor. One of these resistors, I'm going to guess. I can kind of see the traces through this one right here. 4.8 volts to the base of the transistor is going to turn it on. So this thing's trying to turn the pump on, which it is, turned on, because we got right here's the pump pin. We got 4.8 volts. But it shouldn't be trying to turn it on. Let me see. This is the off-on switch right here. So if I put this on here, we got our 4.8. It does nothing. And we know the switch is working. I really feel like the program's corrupt in this thing. It does display an L at some point. Looks like there's something in here working, because it does detect these switch closures, but it doesn't do what it's supposed to do. Yeah, so this transistor, I'm assuming it's working, because, I don't think we need to take that any farther at this point, because the base is on, the power is going through to this lead. So I think that's good. 5-volt regulator is good. I don't know about this oscillator, this crystal. And I'm not going to see anything. The meter, I might see some voltage on it. 1 volt, 2 volts. I don't know. You got any circuit board repair guys out there to have any ideas? I do know this is a very simple board here. It basically has one input and one output, one dry contact input and one output of 5 volts, basically. So I can replace this with an Arduino board in like 10 minutes. But, the guy has his tub. This fits in the box, the panel for the switches, makes it all look good, So it'd be nice to get it working. I mean, worst case, I think I will just maybe program a little Arduino board for him. I wish I knew exactly what kind of voltage is coming in here. It's going to be pulsating DC, I'm guessing, because I don't see any kind of real. Oh no, yeah, because this voltage regulator here. I wish I had a scope. Oh, and I don't have the voltage coming from the actual coming from this power panel anyhow. So, I'm just wondering the voltage coming from that, if it's a pulsating DC. This even says 12 volts. I mean, an Arduino isn't going to like that very much. So I would have to clean that voltage up first. Well, maybe I could use this board in conjunction with an Arduino, pull this chip out, and supply the 5 volts to the Arduino from here. I could probably do that, especially if I got a little, not an Uno board, but a Nano, one of those little Nano. However, they run on 3.3 volts. But I could take his 5 volts probably and just make a simple voltage divider with it. And I wonder why this transistor is probably isolating this output so the chip doesn't have to drive that solid state relay. So I could still use that as well. Although I bet you an Arduino would drive that solid state relay. I don't have the specs on it. I don't know, maybe not. I could keep this the same and just take this chip out, tie my Arduino output to this pin for the motor to turn on. This is just an input, a very simple input. That's just a dry contact to ground. So I could pretty much do the same thing with the Arduino. I could figure out where this is going. I'll bet you there's a resistor here tied to 5 volts and ground. That this, figure out where that's going, tie that into, actually it goes to, I thought I knew where it went. Oh yeah, I think it goes to pin 6. Let's see. 1, 2, 3, 4, 5, 6. I looked this one up, I think. Yeah, there's that 1.86 volts. Yeah, coming from the float. Actually, right now the float is not connected. It's just open. And if I short it to ground, we're going to see. See, I short it to ground. Yeah, so it is that pin 6. So I could just tie my input right here. Either going to be, if it's 1.8 volts, it's high, and if it's 0, it's low. That would work on the Arduino. This could be pretty easy, and a Nano might fit like in here somewhere. Actually, let me grab a Nano real quick. Let's take a look at it. I don't want this video to get too long, but I think this stuff's kind of interesting just to kind of think my way through this thought process. Let's see what I got. This one's got some hot glue on it, but it, yeah, it's actually smaller even. So if I got a regular Nano, I mean, I could clean this one up and use it. Um, that would work. Now, here's where I want to think about taking this. First of all, I think it'd be cool to try to learn how to program a P8048H Intel from 1977 microcontroller. I think that'd be pretty cool, right? To learn how to program that thing. And if I'm able to, I don't know, download some kind of programming environment and try to give it a program, give it a new program, just see if it works, you know, that would be pretty cool. So I'm going to look into that first, actually. So I may have another video pretty soon about this circuit board here. And if I'm able to do that, I'll film what I'm doing as far as trying to get that thing programmed. It could be that the chip is just damaged, and you know, maybe the program is still good, but you know, maybe these outputs are damaged in some way, that they just like this motor output is just stuck on, or this input for the float is just stuck off inside there or something like that. You know, so I could learn how to program it, send a good program, and it still may not work. But I think it'd be cool to try. So I'm going to look into that for the next video. And then if that doesn't go anywhere, then we will get us a Nano and we'll video that, making a little program for it, get it wired in there, and get this thing working again. All right, cool. So stay tuned, everyone. Thanks for watching, and we'll see you on the next one.